Okay, so let's do this one more time. We're going to use the same problem, but now we're going to do a 95% confidence interval. So, just to rewrite some of the information, we had a sample size of 100. We had a mean weight of 425. That was our sample mean. They told us the population standard deviation to be 900. And now we're not doing 80%. We're going to do a 95% confidence interval. I'm going to label it CI. Okay, so the first step is always to figure out your critical value, your Z value, your Z star. Quick note on this. Hawks doesn't use Z star. They use this funky notation Z sub alpha divided by 2. And that's a lot. It's a little crazy looking. So we're just going to refer to it as Z star. Just a little bit easier notation wise. And again, to figure this out, you're going to look at this chart. When you're doing your homework, have your notes open and ready with this chart. And we're doing a 95% confidence interval. 95%, and that means my Z value, my critical Z value is 1.96. So that's what I'm going to use in our formula, 1.96. Okay, so that was step 1. Find your Z value based on the confidence interval. Step 2, let's actually calculate the error. Let me put that in black. So the error is your Z value, your critical value, times the population standard deviation divided by the square root of the sample size. So we'll have 1.96 times our standard deviation, population standard deviation was 900, over the square root of 100, because there was 100 people, 100 items in our sample. What was it? It's not people. Car engines, 100 car engines in our sample. Okay. And then we calculate. So if you're taking this in steps, we get 1.96 times 90, and multiplying that, you should get 176.4. Okay, so that was step 1. Step 2. Now, last step, step 3, is actually build the interval. And, I'll break it up into 2 pieces. The lower bound, it's going to be your X bar, your sample mean, minus the error. So we had 425, and then it'll be minus 176.4. Whoop. There we go. And then we had an upper bound, and that's the sample mean plus an error, which is 425 plus 176.4. All right, so the confidence interval that we have just constructed for this sample is, well, once you do the addition and subtraction, you should get 248.6 to 601.4. All right, and that's your answer. Just double check how Hawks wants you to put that in, but just to kind of reiterate what this means. So basically, we believe there's a 95% chance that this specific interval, sorry, my pen is having a hard time writing on my pad here, interval, contains the true population mean. Because once again, this is all about using sample statistics to estimate population parameters, which we don't always have. And, providing a range of values is a little bit better than providing exactly one value, right? We're more likely to be correct if we provide a range of values. And we are 95% sure that this interval will in fact contain the true population mean. And again, another way to look at it is if you take all possible samples, 95% of those samples will contain the true population mean, where the other 5% won't. So again, that's just two different ways to talk about it, but it means the same thing. Okay, so that is how we calculate an interval, confidence interval with a normal distribution. When you're working on these problems in Hawks, your signal that you need to use this process is if they tell you that it's normally distributed. Or also, we'll have a pretty big sample size, usually bigger than 30. So let me make that little note. If you have a sample size bigger than 30, you're usually going to use the normal distribution, or z tables. Well, the z value. Okay, in the next video, I will be presenting another way to calculate confidence intervals.